Okay, here we go. Linear programming. I'm starting on the wrong screen there. Linear programming. Kind of a long process here. I'm just going to give you a few examples. And here's kind of the setup. Give me one slight moment for my board to kick in here. Okay, here's the process. You're going to want to have this in your notes. I'll have it before every example, but you only need to write it down once. First, you need to define the variables, and then the second thing you do is make a table. A lot of process. I'll go through the process as we go through a problem because it'll make more sense. I have to be honest with you. Sometimes I make a table and then I define the variables because sometimes it's easier once you have it laid out in a table. Step 3, write a system of inequalities. Basically, you take that table and you turn it into math. Number 4, you graph the system. 5, you find the vertices. Number 6, you write a linear function, which is a max or min statement. Then you substitute the vertices into your max min statement. And then the final thing is to answer the question they're asking in the problem to begin with. So make sure you have that copied down. These are the steps you're going to take. Now let's let it make sense with an actual example. Okay, the furniture company manufactures 2 types of desks using oak and mahogany lumber. The first type requires 10 board feet of oak and 5 board feet of mahogany, whereas the second requires 6 board feet of oak and 4 board feet of mahogany. A profit of $45 is made on each desk of the first type and $30 on each desk of the second type. From a supply of 1,000 board feet of oak and 600 board feet of mahogany, how many desks of each type should be made in order to yield a max profit? Now, that looks overwhelming. However, if you were working for a company or you owned a company, this is the kind of stuff you would deal with. You would say, I want to make this item and this item. Probably it's actually more complicated because you're probably making more than 2 types of items for your company. And then you look at the supplies you have. How can you maximize the supplies you have? How can you get the max profit? Or you're going to see with some of these problems, you're looking at the minimum cost. What's the minimum cost for something? Okay, so first thing we do is, what is that? Step 1, define the variables. A lot of times you can just look at the question and that will get you kind of going on what you're looking for. They want to know how many desks of each type. Okay, so you have a first type and you have a second type. I know they don't say first type and then the second type of what kind of furniture is. It's oak and mahogany. 2 different kinds of desks. You have a first desk and a second desk. So those are your variables, and once again, we'll look at that again after your second step, which is make a table. Now here's kind of what I do here. I have 2 different things I'm looking at. I'm looking at oak, and I'm looking at mahogany. All right, there's the first type of desk, and there's a second type of desk. All right, the first type of desk uses 10 board feet of oak. And I think that's just like when you, this would be a Mr. Talley question, but basically you can get, how long do you want that wood to be? I think there's a certain width of it already. The second type is 5 board feet, I'm on the first type still. So 5 board feet of mahogany. So here's my mahogany, here's my first type. I put that in the chart. The second requires 6 board feet of oak, so I have 6 board feet of oak, and I have 4 board feet of mahogany. Now here's the cool thing, I'm going to go ahead here and they talk about, I'm going to skip the profit. Anytime they talk about profit or cost, we're going to wait just a minute on that piece of information. So hold off on that, we'll get to it. Okay, from a supply of 1,000 board feet of oak, so here's my oak. I'm going to say, hey, I've got 1,000 board feet of that, and then I have 600 board feet of mahogany. So I'm going to put that right here because I'm going to keep that in line with the mahogany. Okay, now I've got my table set up. And double check. Does it seem like I need to find how many of these desks am I going to make? How many of those desks? Okay, write the system of inequalities. Basically, we turn our table into math. So I'm going to call this first my x and my second my y, because those are my variables. So I just write this out. 10x plus 6y, and here's the kicker. I only have 1,000 board feet of oak to work with. So if that's the case, then I can only use less than that amount, or I can use exactly that amount. Mahogany, 5x plus 4y is less than or equal to, in this case, 600. Now, if we set our tables up like this, they actually could be the other way, like, I don't want to get too much into that. What if you put oak and mahogany up here and first and second over here? Well, then your numbers would be down here, but the idea is still the same. 10x plus 6y is less than or equal to 1,000. 5x plus 4y is less than or equal to 600. So now we have converted this into mathematical inequalities, and I'm just going to jot this up here for a minute. Could you have a negative number of desks or a negative number of this kind of desk? Probably not. So we're going to say x has to be greater than or equal to 0. You could have 0. And y has to be greater than or equal to 0. So this is what we call our system right here. Our system of inequalities. All right, so that's this line right here. Going on to the next one, we're going to graph this system, okay? You're like, whoa, I have to graph that? That's just crazy. So I'm going to go ahead here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm calling this 100. Let me make sure I counted correctly. Yeah, I did. And then I'm going to go out. There's another 100. Oh, so it's 200. Silly me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm going to do the same thing up this way. So this is probably 50. 1, 2, 3, 4, 5. This is 100. This is a lot of fun. 150. Okay, and then 200. I think that might be all I need. We'll see here. All right, now you have a choice when you do your graphing. This is in standard form because our next step is to graph. So number 1, we could switch it to slope-intercept form, but I think once again your best bet is to go with 0 blank blank 0. You don't have to. If you want to switch that to slope-intercept form and go for it, go for it. I'm going to do 0 blank blank 0 because I think it's going to work out kind of nicely. All right, so I've got 0. Okay, and that's once again if I cover up the x's, then I have to take 1,000 divided by 6 if I do that. I curse my hand, I can't, how do I cover that up? You're going to get 166.67, okay? And then if I go the other way, 0 blank blank 0, that means I put a 0 in for y. 6 times 0 is 0. So 10 times what equals 1,000? 10 times 100 equals 1,000. So basically, while I'm working with my red pen here, I'm going to get this graphed on here and get it shaded as well. I think it's best to do that all in one step before moving on. So 0 with 166.6. So here's 150, here's 160, 160. Okay, it's probably right in here. There's my y-intercept. My x-intercept is at 100, 0. And oh, I'm supposed to make some kind of a straight line with that. Let's see what I can do. And I think I would like, I might not be able to do like, here we go. Am I in red? The question is, am I in red? It's not doing it in red. I swear I pressed red. Oh, I need red right here. Sorry. Okay, so there's my red, and here we go down through this one. Okay, looks good. I'm going to put little arrows to say, yeah, that keeps going. Now I'm going to switch to green for this one right here. 5x plus 4y equals 600. So once again, I'm going to put 0 in for my x value. If I cover up 0 times 5, then I have to take 4 times what gives me 600, and that would be 150. And then I go ahead and I put 0 in for y, and then 0 times 4 is 0. So 5 times what gives me 600, and that would be 120. So then I have 120 and 0. All right, so this works out pretty good. Let me graph that. 0, 150 puts me right here. If you don't have colored pencils or anything, you know what you can do? You can just put like a different symbol, like squares, or you can put stars in place just to keep it straight when you're at home with just a pencil. And then 120 goes with 0. So here's 100, here's 120. I'll put a star there. And then I'm going to make a line that goes through this whole thing, and I'm going to make it green. Uh-oh. Do I do green there, or do I get green? I can never remember which one controls which. Okay, so there's my green through my green. Okay, they look very similar, those two lines. There is an intersection, just kind of want to point that out in advance. Oh, I forgot to shade. Silly me. Oh, let me go back just one moment. Not that big of a deal, but 0, 166.67, and 100, 0. If I'm going to shade that, if I put 0, 0 in here, 0 is less than or equal to 1,000. That means this point is true for the red. So I would shade with the red underneath the red line. Okay. I'm going to just quick, I'm going to check to see if I can lighten that up just a little bit. I think I can. Oh, isn't that fun? So there I've got my green. Oh, what should it have been? Should have been red. Hold on, maybe I can do that. I feel like now I'm taking way too much time to like get you guys all straightened out. No, I would do this bucket. I would say red, and I would, oh, look at that. La, 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 la. So, all right, now the next one is in green. So underneath the green line, I'm going to put, I got to check, is it underneath? I put 0 in here, 0 in here. 0 is less than or equal to 600. So I'm going to shade underneath the green line. Now let's see if I can do this accurately. Green. I'm going to shade green. And then here. Okay, now, let me once again make that just a little bit lighter so it's not quite so overwhelming our picture. Now, x is greater than or equal to 0. That's basically everything to the right of this, and y is greater than or equal to 0 is everything above here. So anytime you see this, basically means you're in the first quadrant. And I try not to overthink this too much. You're just not going to have negative numbers oftentimes. I can't say every single time. So basically, our solution to this system is here, and it comes down to this intersection, and then I'm going to be bordering on the red line. And those are solid lines because we're including that. And then we stay on the x is greater than 0 and y is greater than or equal to 0. And that keeps us in this little area. So this is what we call our feasible region, this area right here. Okay, so now we've got it graphed. Now let's go back. Then we find the vertices. Now what's a vertice? What are we looking at for vertices here? I'm going to keep this in black. Your vertices are like the corners of your feasible region. So like this is a corner. You come over here. This is a corner. Get this. There's actually a corner right here and a corner right there. So that shaped graph looks kind of like a triangle, but there's actually a vertex right there. So we actually have 4 vertices. Okay, and we have to find the value of those vertices. All right, well, this one's easy enough. I got 0, 0. Everybody agree with that? Oh, sure you do. This one's easy enough. I have 0, 150. This one's easy enough. I have 100, 0. The question is, what's this value? And I know a lot of you are like, oh, I think it's about this or it's about that. Guess what I have to do? I have to find what that is exactly. I have to take this inequality and this inequality, and I have to find where they intersect. Okay, so I'm going to scroll down here. And basically, I need to know, oh, whoops, a little too much. I need to know when this green line is equal to the red line. I want to know what this x and y value is. And basically what we do is we set up a system. We say 10x plus 6y, in this case, is going to be equal to 1,000 and then I set 5x plus 4y is equal to 600. All right, and that's my system. And I need to find x and I need to find y. Well, you can either use substitution or elimination. And I'm looking at this thinking this is elimination the whole way. This is going to be. So if that's the case, then I need to have a variable eliminate. So I take this entire equation times -2. So my new system is actually, let me rewrite the top, is equal to 1,000. And now I take -2 times 5x, I get -10x. -2 times 4y is -8y. -2 times 600 is -1,200. Now I add 10x plus -10x, gone. 6y plus -8y is -2y. And 1,000 minus 1,200, or plus -1,200, is -200. Y is equal to 100. I go back, I could put it in one of the two equations. I think this one looks slightly easier right now. So I have 5x plus 4y, but my y value I've already figured out is 100, is equal to 600. 5x is plus 400 equals 600. 5x equals 200. X, divide both sides by 5, is equal to 40. So that means the solution to this system, this intersection, is located at 4,100. Okay, moving back to the problem at hand. I was looking for this vertex so I would have all 4 vertices listed. 4,100. Okay, I know we've done a lot of work, but this is how linear programming goes. All right, let's go back. I found my vertices. It says find the vertices and then write a linear function. Write your max or your min statement. Either it's a profit statement generally or it's a minimum cost. How can you minimize your costs are the kinds of questions you run into. So we go back to the original part of this problem and it says a profit of $45 is made on each desk of the first type and $30 on each desk of the second type. Okay, so my profit statement is going to be something like 45x, because my first type of desk is the x, plus, what did it say again? $30 on each of the second type. So you got a 30y. Okay, you think, man, is this problem ever going to end? It's the problem that never ends. It will. Okay, the next thing we have to do is substitute the vertices into the max-min statement. So in other words, I have to take all of these points and put them in this equation. So I'm going to, just to try to keep myself on the same page here, this is going to be our profit. If I put 0 in for x and 0 in for y, well, we all know that's going to be 0. We definitely don't want to make, if you're running a business and you're making no desks of the first type and no desks of the second type, you're going to be making no profit. You can imagine how it works. Now, if you make no desks of the first type, so this is 0, and you make 30 of this other type, so 30 times 150, let me grab a calculator here, find that number, 30 times 150 is what I said. That'd be $4,500 is your profit. Okay. $100 for x, so 100 times 45 is 4,500 as well. I don't get to add any to this. And then get this, 40 times 100. So, not 40 times 100, excuse me. 40 times 45 is 1,800. Plus 30 times 100 is 3,000. So if I add those together, then I'm going to get $4,800. Okay, you can probably see that one coming, but it will not always be the case. I know it's likely to say, hey, that'll always be, this one out here might be my maximum profit, but you cannot say that. All right, let's go back. What do we have left to do? It says substitute the vertices we did, answer the question, basically. How many of each type of desk should be made in order to yield a max profit? So our answer to this question is actually this right here. We need 40 of type 1 and 100 of type 2, and we will make a profit of $4,800. That is a scoop right there, folks. And that is how you can do linear programming. Your first example, and unfortunately, not your last example. Or is it fortunately not your last example?